Today's lesson is going to be twofold. The first thing we're going to do is we're going to introduce the concept of adding an extra parameter to equations. That might sound a little complicated. It's actually quite simple, at least on several levels. So what we're going to do is we're going to add in an extra variable. And the first thing we're going to do is we're going to look at a parabola example, and we'll talk about a little bit easier example with a line. So here you have what we've done, we've separated x and y into two parts. So you have the x equation and you have the y equation. You can think about this as an xy coordinate plane. X is governing the horizontal changes, and y is going to cover the vertical changes. And in this example, the goal here is to take the two parametric equations and combine them back into one equation that we recognize as the parabolas form. And so what we'll do is we're going to take the non-squared equation. In this case, that's going to be 3t equals y. I'm going to solve this for t, and then we're just going to substitute that into the t in the first equation and just simplify and be aware that we're going to make it look like the original parabola equation. And that's basically it, right? So first step is really simple. We're going to take that first equation, the vertical equation, and we're going to set that equal to t, and then you're going to get y over 3 equals t. Done, that's it, right? Next part, we're going to substitute that equation, the y over 3, into the horizontal, the x equation, in place of t. So we get x equals the y over 3 squared minus 2. And I'm going to simplify this a little bit. Now, I know what the parabola's equation looks like. If you don't remember that, grab your notes, go back and look at what that form is, or grab your formula sheet for the conic sections and just look at it. The goal here is to go ahead and solve this for the squared variable, right? So once I went ahead and simplified the squared part, I'm going to be basically adding 2 to both sides, and then we'll multiply 9 on both sides, and that will basically be the end of the example. Right, so you end up doing something like this. And so here, I knew what the parabola's equation is supposed to look like. I knew I needed to get the whole number on the non-squared side. And then, and this was it. I didn't have to go any further. And you'll find in a lot of cases, this is what you'll end up having. And now you could end up having fractions here, whole numbers here. It kind of depends on what happens. If I had 9 over here, then I would end up 1/9 at the end. If I had 1 over 9 here, like you see in this example, you'll end up with a whole number there. So don't let that freak you out. But that's it. I essentially started with 2 equations, and I converted them from the 2 pieces, solve it for t, and you're going to get one equation like this, substitute in, simplify anything you need to first, like where we had the squared part, and then solve it for the squared term. And that's what I did here. And so that's your parabola. We're going to do this one kind of together. If you haven't, I'd like for you to try this on your own. So pause it and try the same example. This is one that's only a line. There won't be a lot of x squareds and y squareds involved. See what you get, and then we'll come back. Now, it doesn't really matter which one you solve for. I could solve both of them for t and then set them equal to each other. I could use one to solve for x or for y and then substitute in. Since we did substitution last time, I'm going to basically take the same approach. So we're going to say, I'm going to set the first equation, x plus 3 equals 2t, and then we'll divide by 2. So we have x plus 3 over 2 equal to t. So my goal here was to find one of the equations and set it equal to t. And now we're going to substitute that into the other equation. So here we have y equals 9 minus 4 times x plus 3 over 2. And here comes a nice easy step where I'm just going to do a little bit of simplifying. And so we'll end up saying y equals 9 minus, I'm going to go ahead and I'm going to multiply the 4 in, but I'm not going to do the multiplication because I want you to see what's supposed to happen. So Here it'll be 4. That's like 4 over 1, so be careful. It's 4 times x plus 3 over 2. Now, I could have canceled to start with, but I don't want to skip that step with you. So I see here that the 4 and the 2 can simplify. The 2 goes into 2 once, 2 goes into 4 2 times. And so you end up with 9 minus 2 times x plus 3. So that's what really happened. And you definitely could have gone straight from this step to this step easily. Let's simplify that one, and we'll be done. Don't forget to distribute the negative. So the total equation would be y equals negative 2x plus 3. And there is your line. And it doesn't matter if you started and you did it the other way around. If you had solved for this one and plugged it into this one, you would eventually have one equation with x and y in it, and they would both be the same both times. This is probably the easy version. I would imagine the parabola is probably the harder one. We're going to do one more example, and this one is a circle. The circle is one that you're going to want to memorize its pattern. This is going to require us to remember a few things, but ultimately this is a very obvious one that we'll see. As you'll notice the initial starting place. We have kind of this odd thing happen here. X equals 2 cosine t, y equals 2 sine t. And this part, you may see this show up from time to time. That doesn't really matter. You're not going to even really consider that. But when you get something like this, okay, if you remember, when we talked about some of the complex numbers, you had y equals r cosine theta, r equals r sine theta. That's definitely related. And so what we're going to do here is we're going to solve this for the trig functions. But we need a formula to work with. We need something that we know that it's true all of the time. And so do you remember that little formula right there? And this is the form we're going to take. We know this is a true statement. So this is always true. And so what I'm going to do is I'm going to solve it for sine and for cosine in these two equations. And you see me do that right here. And it's really straightforward. The first thing I do is divide by 2 on both equations. And that might not be a 2. It could be 4. It could be 6. But they'll be the same number. And you'll get fractions that look like this. What we're going to do is we're going to substitute into this equation right here. And then we're just going to kind of simplify. Again, I'm also coming under the impression that I know what the circle's equation looks like. So I'm going to be looking for that. And so you see me just take an extra step to plug it in. So I took this one and plugged in for cosine t, right? Or sine t. There, I think I put cosine first. Doesn't really matter. And so they're all added together. So I went ahead and plugged them in like this. And I'm going to square both terms and just do that little simplifying here. Now, so you're going to get x squared. You're going to get x squared over 4 plus y squared over 4 equals 1. But we know what the formula for a circle is supposed to look like in its conic form. And so we want it to look like this. And so I'm going to go ahead and multiply each fraction by the denominator that we have here. Whatever that denominator is, you'll just multiply each one. It'll just cancel these out, and it'll be equal to that denominator right there. And here you end up having a circle with a center of 0, 0 and a radius of 2. I would take a minute, think about this particular set of equations, the parabola, the line, and the circle. If you need to take a few minutes and go back and watch these again, these are the patterns that you're going to kind of see from time to time. Some of them are very straightforward, and if you can recognize what I did here today, then solving these shouldn't be too big of a problem. Here's one more example for the circle that I just wanted to do with you. So we're going to go ahead and do what I did last time. We're going to set x over 5 equals cosine t, y over 5 equals sine t. Again, we're going to be using I think this time I wrote it like this, cosine squared x, or theta, plus sine squared theta equals 1. I do it this way because in the circle equation, it's always x, y in that particular order, so we'll set it up like that. So we're going to do it x over 5 squared plus y over 5 squared equals 1. And so we'll end up with x squared over 25 plus y squared over 25 equals 1. So again, you get something really straightforward. And you probably can recognize the answer if you do this a couple of times, probably before you even start. But here's the math to get you to that answer.